Hi, my name is Milan, and in this video we're going to talk about Amazon's relational database service. It allows us to easily provision a relational database in the cloud, deploy it in a highly available scenario in multiple availability zones, and even scale the read side of our application with read replicas. Before we dive into the details, I want to give a huge thank you to AWS for sponsoring this video and helping me bring AWS closer to the .NET community. Now, if you open up the AWS console and search for RDS, this is the service that is going to show up. Here's a brief summary of what Amazon RDS is. RDS stands for Relational Database Service, and it allows you to provision relational databases in the cloud. And what's really cool about RDS is that you can choose from multiple relational database engines. Amazon RDS makes it very easy to spin up a relational database without you having to think about provisioning infrastructure, managing the database engine version, licensing considerations. All of that is taken care of by the RDS service, and all you have to think about is which database engine you want to use, and then connecting it to your application and start building. I said that you can choose from multiple database engines, and here is what's supported in Amazon RDS. We have Amazon Aurora, which is a MySQL and Postgres compatible database, and this is an AWS specific product. And then you can choose from some of the more popular database engines such as MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server, and IBM's DB2. So now let's jump into the AWS console, and I'm going to show you how to spin up an RDS instance, and then we're going to see how we can connect to it from a .NET application. From the AWS console, you can navigate directly to the RDS service if you already used it, or you can search for RDS and the relational database service is going to show up. From here, you can go ahead and click Create Database, or you can go into Database Instances, which is going to list the available databases that you created before. Since I don't have any, I'm going to click Create Database and show you how to set up an RDS instance from scratch. Now, the first thing you get to choose is the creation mode that you want to follow. You can choose between Standard Create, which gives you more customization options, or an Easy Create mode, which is going to apply some sensible default values to the database engine that you choose. I recommend that you use the Standard Create approach because it gives you much more control into your database setup. The next thing you can choose is the database engine that you want to use. The first two options are Amazon Aurora. You can choose from a MySQL or a Postgres compatible database, and this is an AWS specific offering. Then you can choose from the popular database engines such as MySQL, MariaDB, Postgres, Oracle, SQL Server, or IBM's DB2. I'm going to use Postgres for this example, but SQL Server is also supported and is probably the most popular database among .NET developers. The next thing that you can choose from is the database engine version that you want to use. I'm just going to pick the latest version for Postgres, which is 16.3. Once we have chosen our database engine, then we can decide which type of database we want to deploy. You can choose from a production template, a development or testing template, or a free tier template if you want to try out RDS without additional cost. Be aware that the option that you choose here is going to affect how powerful of a database you can create. So if you need something with more resources, then you should choose a production or development or testing setup. But if you just want to try out RDS, you can choose the free tier option. Also, if you want to deploy this in a highly available setup with multiple availability zones, then free tier doesn't support this. Nonetheless, because I'm just demonstrating how to use RDS, I'm going to pick the free tier template. Then let's proceed to the next section, which is the database settings. And here you have to give your database a unique name, and I'm going to give it the name of eShop Primary Database. Then you can configure your credentials if you want to manage them yourself, and the default values for Postgres are the Postgres username, and then you can choose which password you want to use. I'm just going to type Postgres, which is obviously a very weak password and you shouldn't be using it in production, but because this is just a demonstration, I can go ahead and use that password. Also, you can let AWS generate a strong password for you by selecting Auto Generate Password, and you will be able to see the password value once the database is created. Of course, you can also store the password in AWS Secrets Manager if you want to go down that route. I'm just going to use a self-managed approach for this example. Then let's proceed to the next section, which is where we get to configure the instance type that we want to use. I'm going to choose a DB T4 micro instance. The T4 instance should offer slightly better performance, so this is why I'm choosing it. The next thing to configure is the amount of storage that you want to use. The default value is 20 gigabytes, And you can also configure if you want to use storage autoscaling, which is going to increase your storage amount if your database reaches a certain size. I recommend that you leave this on and let AWS handle scaling the storage. Then we get to configure connectivity, and the most important thing here is which VPC or virtual private cloud you will be using. I'm going to use the default VPC, and I'm also going to use the default subnet. Now the next setting here, public access, is important if you want to be able to connect to your RDS instance from your local machine. I'm going to choose yes for public access because I want to be able to connect to it. However, be aware that this does decrease the security of your instance. Ideally, you want it to only be available inside of a virtual private cloud. Then I'm going to choose my VPC security group, and I'm just going to use the default one. Let's leave the default values for everything else. For the database authentication, we already chose password authentication. When it comes to monitoring, I'm going to leave performance insights, and I will leave everything else with the default values. At the bottom, you will be given an estimated monthly cost for how much it's going to cost you to run this RDS instance. You can see it comes out to about $14 a month if your instance is running all the time. However, since we chose the RDS free tier, we won't be charged anything. Now, if you want to get some free AWS credits, you can do that from the link that's going to be in the description under this video, and you can get some credits to play around with the AWS RDS service or any other AWS service that you want to try out. And we have pretty much configured everything that we need to spin up an RDS instance. So I'm going to click Create Database, and this is going to start creating my database behind the scenes. The database creation process usually takes a few minutes, so you can go ahead and grab a cup of coffee or a cup of tea if you are like me, and when you get back, the database should be ready for you to use it. After a few minutes have passed, you can see that our database is now ready, so I can navigate to my database instance and we can see what we have inside. I'm going to close down this notification, and then let's take a look at our database. You can take a look at your connectivity settings. You can monitor your database through CloudWatch. You can take a look at some logs. You can see what the current configuration for your database instance is, and a few other options. Now, what I want to focus on is the connectivity option for a moment, and I'm going to go into the VPC security group. If you recall, we configured our database to have public access. However, you still won't be able to connect to your database from your local machine unless you configure a network rule in the security group. So if you navigate to the security group that you used for your database, you can observe your inbound rules, and here you would need to add a custom rule for Postgres on the default Postgres port and set up which IP address is allowed to connect. Now, if you want to manage this from scratch, you would click Edit Inbound Rules. Then you can click Add Rule, choose IP or Postgres, because this is simpler, as it's going to set the default port right away. And for the IP address, you can choose My IP. And this is going to allow your IP address to connect to the RDS database. Now, since I already have everything configured, I'm just going to leave the options that I already had in place. So let's close this down, and I'm going to go back to my RDS instance, and let's see what else we have over there. So let's head over to DB instances and then into my eShop primary database. Now, the next important thing that we need is the actual endpoint or the host where we can connect to our database. And this is what you're going to specify inside of the connection string. So let's jump into a .NET application that's using EF Core and Postgres and see how we can connect to our RDS instance. So here is my .NET 8 application, and I'm just configuring a database context to use Postgres, and I'm specifying a connection string from my application settings. The database context itself contains just one database set, which is a product, and this is going to match the respective table in the database. I'm also applying database migrations when the application starts if I'm running in a development environment, and this is going to make it easier for us to create the database instance inside of our Postgres instance. Now let's go ahead and set the connection string value inside of our application settings, and I already have a template here which has most of the things configured for the Postgres connection string, but I'm going to specify the host with the value that I picked up from the AWS console. So this is the host address for our Postgres instance. Then the default port is 5432, the username is Postgres, and the password is also Postgres because I didn't want to create anything more complex than that. And this should be enough for us to be able to connect to the RDS database. So let's go ahead and start the application. And the first thing I want to do is to show you some logs when the application starts. and you can see that our migration is running. So we are creating the eShop database, creating the migration history table, creating the products table, assuming all of these don't exist, or in other words, the migration wasn't already applied. And if everything succeeds, and it did, we're going to start our application. If I open up the Swagger UI for this application, I should be able to create a new product. So let's say gadget with a price of 1, 2, 3. And if I send this request, you will see that it succeeds and we get a response back. Now I should be able to query the database, and you can see that we have one product available. I should be able to query the product by ID, and you can see that the product is there. So our API seems to be working, and the connection from EF Core to the RDS database also seems to be okay. Now let me show you how you can connect to your database directly from some database management UI. I'm going to be using DBeaver, but the same applies if you're using something like pgadmin. If you open up DBeaver, you can go ahead and create a new connection, and I'm going to choose the Postgres template, and here you would have to configure your host to your specific database, the port if it's different from the default port, which database you want to connect to, and then you should be able to connect to your database instance. Now, I already configured a connection while I was testing, where only the host is different, so I'm going to update the host value. You would have to specify the username and password. The database is called eShop, and the port is the default port. Let's go ahead and test our database connection. And if this succeeds, I'm going to say okay, and then let's connect to this database. So we should be able to connect to our database, and when this succeeds, I can open up the database schema and see the tables that I have inside. So here is the EF migration history table, and if I open up the data, you can see that we have one migration applied, which is the create database migration. And then there is also the products table, which contains just one product, so everything seems to be working as expected. Now let's discuss how we can scale our database with Amazon RDS. There are two ways how you can scale an RDS instance, and I'm going to discuss the first approach, which is more concerned with high availability, and this is using Amazon RDS in a multi-availability zone setup. So the multi-AZ setup allows us to have high availability with RDS by deploying multiple database instances in different availability zones. In that case, when the primary database goes down or the availability zone is cut off, you can have automatic failover to one of the availability zones that you have configured. The failover time ranges from 30 to 60 seconds, depending on the setup that you choose, and this also allows you to have separate read and write endpoints for your applications, which could allow you to scale the read and write side of your application independently. So this is the simplest multi-AZ setup for Amazon RDS. You would have one primary database, which is the database that you are writing to and reading from, and also a standby instance in a different availability zone. These databases are kept in sync using replication, and if the primary database fails for whatever reason, you can fail over to the standby instance and continue using that, which minimizes the downtime of your application. There is also a more advanced setup with a primary database in one availability zone and then two standby databases in two different availability zones. This also gives you the ability to have one endpoint for your application writes and another endpoint for your application reads. So if you want high availability and scalability, this is something that you can look into. Now, if you don't need high availability, a multi-AZ deployment, and automatic failover, and you just care about scalability, you can look into the Amazon RDS replication feature. What this allows you to do is to configure a read replica of your primary database. The read replica is kept in sync using asynchronous replication, and I have to note that read replica support is going to depend on the database engine that you choose. For Postgres, this is natively available. For SQL Server, it's only available in some editions of the SQL Server engine. Here's an example where the read replica is in a different availability zone, but you can also have it in the same availability zone as the primary database, and having a read replica allows you to have some very interesting behavior inside our applications. First of all, you can dedicate all your application reads to go to the read replica, which is going to offload some traffic from the primary database, which is only going to handle writes. Secondly, you can always promote the read replica into a primary database in case the actual primary database goes down or becomes corrupted for some reason. Now, let's jump into the AWS console, and I'm going to show you how to set up a read replica. If I open up my RDS instance, I can click the Actions dropdown, and I can say create read replica. Alternatively, you can go to the list of your databases, click the database that you want to create a read replica for, and then from the actions dropdown, also click create read replica. So let's go ahead and do that. And this is going to open up a wizard for configuring the read replica. You also have to give your read replica a unique name. So I'm going to say eShop replica database. Then you can configure your database instance. I'm going to use the same one as the primary database. You can choose which AWS region you want this deployed to. If you want a multi-AZ setup, I'm just going to leave the same one. I'm going to leave the default values for storage with the 20 gigabytes. I'm going to use a single database instance for the availability. Then for the connectivity setup, we're going to use a publicly accessible database in the default security group. We're also going to use password authentication. Everything else I'm going to leave with the default values, and then I'm going to click create read replica. Now, creating the read replica is also going to take a few minutes, and while we wait, let's go back to our application and implement support for the read replica database. I will head over to the database context that we have configured, and I'm going to create a new class which I'm going to call the read-only database context. Let's update the constructor name and the options class that we are passing through the constructor, and everything else remains the same. So this is just going to be a carbon copy of my application database context, but I'm going to configure it to use the read replica database behind the scenes. Now, when I'm configuring my database connection, I'm going to use a different connection string. So let's say the connection string is going to be called read-only database, and I'm going to configure this to point to the read replica, and I'm also going to configure query tracking behavior for this database context, and I'm going to say query tracking behavior no tracking by default. Of course, I actually have to specify the read-only database context here. So now we have two database contexts inside our application: the application database context connecting to the primary database, and the read-only database context connecting to our read replica. We don't need to think about setting up the schema of the read replica. The Amazon RDS service is going to take care of everything. It's going to take a snapshot of the primary database instance, use the snapshot to create the read replica, and then it's going to configure asynchronous replication between our primary database and the read replica. From our perspective, we are just going to use the read replica as the source of truth. So I'm going to head over to the application queries that I have, for example, the get product query, and I'm just going to replace the query here to use the read-only database context. I'm going to do the same in the get products feature. So let's replace the app.db context with the read-only version that's talking to the read replica. Now I also have to configure a separate connection string. So I'm going to copy the one that I already have, and I'm going to paste it here. I'm going to update the connection string name to read-only database, and the only thing that's remaining is to update the database endpoint, which we are going to get from the AWS console. After a few minutes, our read replica database is available, and you can see that it's designated as a replica in the role column, and then we have our primary database, which we created earlier. Now, if I open up the replica database, I can see the connection string, or the endpoint actually, which I can use to connect to this database instance. So let's go ahead and populate this in our connection string in the application and see if our connection is working as expected. I'm going to update the host here to point to our replica database, and everything else should just work. So let's start the application and confirm if this is the case. What I want to test is when I create a few products, let's use the same name and price, or actually let's differ the price. So 1 product, 2 product, 3 products. I just created 3 products in the primary database, and now when I send my application query, it should go to the read replica, and I should be able to see the 3 products that I just created. I also should be able to fetch these products by the ID, and both of these queries are hitting our read replica database. And if I go over to DBeaver for a moment, I already configured the connection to my replica database, and if I refresh the data in the products table, I should be able to see the products that are here. What's going to happen if I try to delete a row from this table? Let's say I delete the row with the ID of 4, and I try to save this, you will see that I'm getting an error because I cannot execute a delete statement as this is a read-only database. The error message specifically says that this is a read-only transaction. So you can't alter a read replica database, it can only be read from. What you can do is go into the products table, add a new row, for example here, and let's say gadget with a price of 1. Now when I save this, it's going to get an ID assigned, which should be the ID of 5. And if I go into my read replica and refresh this, you will see that replication has succeeded, and we can see the new product also available in the read replica. Now let's go back to the AWS console, and I want to show you how to delete your RDS database. From here, you can choose the database instance that you want to delete. Let's say I want to delete the read replica. I'm going to say delete, and then you have to type in delete me, and finally you can mark it for deletion. Let's also delete our primary database. Here you can configure if you want to create a final snapshot and if you want to retain backups. I'm just going to say that I don't want any of this and just mark this database for deletion. And after a few minutes, these databases are going to be removed. Now, if you want to grab the source code for this video and try out this application with Amazon RDS, you can do that from the pinned comment that's going to be under this video. If you are looking for a simple and efficient way to deploy your .NET applications to AWS, then you should watch this video next. Check out my clean architecture and modular monolith courses if you want to improve your skills, and until next time, stay awesome.